Assalamualaikum and a very good day. My name is Syazwan Bin Razak. My matric number is DE170098. I'm a final year student with a PSM 1 under the supervision of Dr.Rohaida Binti Akir. And my title for my PSM 1 is Robot Seed Planter based on distance. Okay, so firstly today I want to talk about the problem statement for my project. That is, firstly, the amount of time to plant the seed is longer. This is due to the human error because humans take time to do the work and they get tired easily. And secondly, the precision of distance between the seeds planted. This is also due to the human error because human cannot measure the distance accurately. And then third, the most of the farmer is old age. And finally, the lack of interest in youngsters nowadays. Okay, so the aim of this project is to design a system that can approximately move the seed planter robot to the place we want to plant the seed automatically. In other hands, it is an unmanned vehicle. So then it will automatically get to the target placements of the seeds. Okay, the objective of this project is, firstly, it is to design a program that can approximately move the robot to the place that has been set automatically. Secondly, it can we are going to evaluate the performance of the program in the real world. Then, the scope of the project. So, the scope of the project is the position and localization of seeds that are planted between each other. So the problem is we are going to plant the seed uh, in a distance that is constant to each other. So each of the seeds can have enough nutrient for them to grow. And then the second one is the FPM Autopilot 2.8 as the navigator of the robot seed planter. Okay, so as for the literature review, okay, so the previous project that I researched is the seed planter with robot by PT Hamanda. So this project used an microcontroller of Arduino Uno, and it used the sensor of line tracking sensor that is BFD 1000. And this project is a project that is based on a line tracking system. So the line tracking sensor is going to follow the path and stop at the desired point, and the wheeled robot will plant and water the seeds. So here you can see at the slideshow the project block diagram. So here he used a 3 servo motor, one microcontroller, one line follower sensor, 2 motor driver, and 3 DC motor. Okay, so for my project methodology, okay, this is my block diagram. So first of all, we are going to use the Q ground control GUI to do the mission planning, and then the task from the mission planning is going to be transmitted from the radio modules of telemetry kit and received by the radio module of the telemetry kit too, and then it will send to the APM 2.8 autopilot. Okay, for the flow chart here, firstly, when we start the program, we need to insert the desired position in the Q ground control, and then after that the Q ground control will send it to the radio module to be transmitted to the APM on the vehicle. So as you know, the radio module for the transmitter is connected to the PC or mobile phone that has the Q ground control GUI running on it. And then after that, the ready modules on the APM on the vehicle will receive the data and send it to the APM autopilot to be decoded and run the task given, and the RC car will move to the desired location. After that, if is no data inputted, it will stop the program, and if the user want to enter a new mission, it will go to the insert the desired position in the Q ground control. Okay, for as the hardware connection, firstly the connection of the component is the motor, so servo from the RCU car will connect to the output pin 1 and 3 at the APM, and then at the PM input pin, it will be connected to the receiver by connecting input pin 8 to the receiver channel 5, and then input pin 3 to the receiver channel 2, and input pin 1 to receiver channel 1. And then as for the GPS module, will be connected to the GPS port at the APM and also I2C port. Meanwhile, the telemetry will be connected to the power port. As you know, the telemetry is the radio module for the telemetry kits. Okay, and then for the software, I'm going to use a Q ground control software. It is a graphic user interface to connect the APM autopilot, and it is one of the software that is easiest to use to do the mission planning, and also it has on mobile phone, not only on computer, and it is an autonomous vehicle GUI application. Okay, for as my preliminary result, I have done the mission planning. So as you can see, firstly I need to alter the altitude for the waypoint to 0 because it is a rover one. So if we use altitude more than 0, it perhaps will not move, because for the altitude it need to be 0 because it is move on land, and I will hold the vehicle for 30 seconds for each waypoint to imply that it is planting the seeds. Okay, so the mission command that I use is the loiter command. Okay, the loiter command that I pick is loiter time. The loiter mean we stop the unmanned vehicle for a moment. Okay, for my selection is loiter time is to travel to a position and loiter the amount of time. So it can shows that the device or the vehicle is doing its job as in planting the seed. For the future work, I will build the mobile robot platform and custom it. That means will custom the placing of the APM, the motor, the servo motor, and second, connecting the APM autopilot with the Q ground control application, and finally test the functionality of the system, whether it works or not, following the task that we given. Okay, so that is all from me, and thank you for lending your ears and time.